Hello everyone, my name is Andreas Papalambrou. I'm from the University of Patras in Greece and I'm going to be presenting to you our astronomical sonification program called A4BD. It's a software that was developed as part of an Erasmus project that the University of Patras coordinated along with 5 other partners from other European countries. And their purpose was to explore this area of giving the blind and the visually impaired in general an opportunity to discover the science of astronomy. The astronomical images that appear on the software have been processed in a very specific way in order to extract some characteristics which are then sonified. First of all, an algorithm that traces the edges, forms the contour, as we would say, of the image, is run onto the image. Second, the image is quantized in order to reduce its complexity because an image that is sonified on a pixel by pixel basis would be too complex. Third, we detect the various levels of brightness across and along the image. And fourth, we detect the colors of the images in every part of the image. Color, of course, is an area which is very complex. For our approach and based on questionnaires and tests that we did with the visually impaired, we decided to use the sonochromatic scale. That is a scale that translates specific colors to specific musical notes. Also, we discovered during demonstrations and tests that a maximum of 10 levels of color, and that also extended to brightness, are the most number of levels, the biggest number of levels that can be introduced in a sonification process without actually making it too complicated for the users. This is not supposed to be a theoretical tutorial, so that's all from the introduction. We're going to demonstrate and learn the software right now.
Let's begin by launching the software. When I launch the software, I will let you listen to the voice instructions, and when the voice instructions are over, then I will explain to you.
Welcome to Astronomy for the Blind and the Disabled application. To navigate into the application, please press and hold the left side of the screen. Provide a valid voice instruction after the characteristic sound and release your finger. If you hear the error sound or the rejection sound, repeat the process. Say play to enter the play mode, say train to enter training mode, or say quit to quit the application.
So after this long instruction, we arrive at the main screen of the program. The program can be used in landscape or portrait mode. What the instruction actually was in brief was that you can press and hold the left side of the screen where the mic is, but even if you don't see the mic because you're visually impaired, you can simply press anywhere on the left side and give a voice command. Train.
The application uses vibration to help you detect the boundaries of shapes. Please swipe your finger in order to detect the shape of the square currently on the screen. Say next to proceed to the next training stage, or exit to return to the main screen.
Okay, so we arrived to the first training screen, which helps us understand how edge detection happens in the application. Edge detection actually happens via vibration, so you are invited to swipe your finger across the screen, and vibration will notify you that you are actually touching the edge of an object. By pressing next,
please swipe your finger across the screen.
You arrive to
in order
another
to
object.
detect
In
the
this
shape
case,
of the
it's a
triangle
triangle
currently on the
that you
screen.
are invited to do the same thing
Say
and
next to proceed to the next training stage.
and understand how a
Exit
triangle
to return to
actually
the main
feels
screen,
with the vibration.
or back to return to the previous training stage.
By pressing
Please
next,
swipe your finger across the screen
you arrive to
in
the
order to detect
object
the
of
shape
a
of the
circle,
circle
which is
currently on the screen.
you can also use to see
Say next
how
to proceed
vibration
to the
works.
next training stage. The application uses sounds to translate colors. Please swipe your finger across the screen in order to hear the two different sounds of the two halves of the square currently on the screen.
As you heard in the voice
Say
instructions,
next to proceed
we
to the
arrived,
next training
we
stage.
bypassed the three
Exit to return
shapes
to the main screen,
that
or
are
back to return to the previous
interpreted
training
via
stage.
vibration, and we arrived to the first color object, which is actually a two-color object. And you're invited with your finger to explore the image and see that this square that is divided in half with two colors, to actually understand how the boundaries and the different colors, how they are presented.
Please swipe your finger across the screen.
Now, the same
order
thing
to
happens
hear the
here,
gradient of
but this
different
time we
sounds
have
of the
a
square
gradient. So we
currently
have
on the
a
screen,
square that
which
has a
fades from
gradient
blue on the left to red on the
that
right.
turns from blue
Say next
to red.
to proceed to the next training
So
stage.
when we reach
Exit to return to
the
the
one
main
edge or the
screen,
other edge, we don't
or
have a
back
jump
to return to the
when the
previous
color
training
changes,
stage.
but instead we have a more linear process where the sound changes as the color changes.
Please swipe your finger from the top to bottom.
Here I can say that you can always press on the left side of the screen in order to stop an audio message. This is what I did because this particular message is repeating itself. This is the final image of the training mode, which actually has the sonochromatic scale itself, the one that we used to make the translation from colors to musical notes. And your users can swipe from bottom to up and hear all the main notes of the sonochromatic scale as we go from red to violet, the edges of the visual spectrum. So I exit the training mode and I'm back to the main screen.
Say play to enter
This
the play
time
mode.
we're
Say
gonna
train
play.
to enter. Choose one of the following astronomical objects by saying its name. Globular cluster, planet Jupiter, comet, Milky Way, North America Nebula, planet Saturn. Say download to explore further astronomical objects from the internet, or say back to go back to the main menu.
So here we are at the main menu. The application comes with 6 images that we have chosen to demonstrate, and also has a download option that you can use to take images from the internet, and these are images that we purposely upload each time in order to fulfill the specific goal of each usage. So let's start, for instance, with planet Jupiter. I can either touch or speak. I will choose to touch this time.
Swipe your fingers across the screen in order to detect the shape of the chosen astronomical object. Say color to proceed to color recognition mode, or say exit to go back to the astronomical object list.
When we open the image of an astronomical object, first we arrive at the edge detection screen, which uses vibration. So here, I don't know if that can be heard on the screen, I'm touching and the phone vibrates every time I touch the edge of Jupiter. In order to proceed to the color recognition mode, which is the second screen of each astronomical image, I can either deselect the shape mode, so I can enter color mode, or I can say color mode using the voice command. I will choose to say color mode. Color.
Swipe your fingers across the screen in order to hear the sounds of the colors displayed. Say shape to enter the shape recognition mode, or say exit to go back to the astronomical object list.
As you heard, I can still go back to the shape mode by clicking on shape or giving it the voice command shape, but of course I will prefer to use sound recognition on Jupiter. So what actually happens here is that I swipe my finger across the screen and I get to hear the different sounds. One thing that must be quite obvious is how the volume changes when you go to the white zones, and how the volume lowers when we go to the darker zones, and how the volume changes when we go to the bright zones. So it should be easily understandable that this is an object that has successive changes of bright versus darker zones. So I will exit and go back to the main screen.
Choose one of the following.
I will briefly press on the left to bypass the message because I already know what it says. And I will choose to press the download button here on top, or actually download. I will give the voice command download. What download actually does is download images that we put on the A4BD server that are specific to the task we are doing at the time. So here, for instance, I have uploaded a couple of galaxy images so that we can test to see if we can understand the spiral structure of the galaxy. Unfortunately, this screen has a bug and does not display an audio message, so for this particular screen one has to be able to touch the exact image that they want to see. So
Swipe your fingers across the screen.
in this case we have a spiral galaxy that it will be very useful during the training to actually see if users will be able to detect that shape of the galaxy.
Choose one of
I
the
pressed
following
exit and I'm back to the to the main screen. I remind that we can use the mic button, pressing on the left side of the screen to bypass audio messages. These audio messages keep repeating, but for people who are visually impaired, it's very easy to get lost. So when every screen loads, we play again the message corresponding to that screen.
Thanks for watching the introduction to A4BD. I hope you enjoy the workshop and have fruitful sessions with astronomy sonification. Thank you very much.